Okay, so today we're going to be talking about order of magnitude. Go ahead and pause this because you have a lot to write and then restart when you are ready to listen. So the order of magnitude is pretty much just a system that classifies very large and very small numbers. This helps us to kind of wrap our head around what the magnitude of what we're talking about for our measurements. So there are rough estimates that are accurate within a factor of 10. Okay, of about 10. So it uses exponential notation, also known as powers of 10. So if you wanted to get an idea of what the powers of 10 are, you can go down here and you can watch this video. You can also use this website right here to kind of interactively maneuver through the entire universe and just see what objects are in our universe that are on the scale of 10 to the 0, 10 to the 16, 10 to the negative 50. Okay, so just kind of play around with that to get an idea. So here's an example. The number of atoms in 12 grams of carbon is approximately 6 with all these zeros, also denoted as 6 times 10 to the 23. Now, 10 to the 23 would be it's like power of 10. But what we want to find is its order of magnitude, okay? And it could very well be 10 to the times to the 20 or 10 to the 23. Sometimes it might be 10 to the 24. And let's go ahead and look at this. So when I'm asking you to find the nearest order of magnitude, what you need to do is you need to take the log of the scientific notation. So in this example, it is 6 times 10 to the 23 from our previous example of the carbon. You're going to take your calculator and put in log, and then 6 times 10 to the 23, close the parentheses, and you should get an answer of this. Now, the number does continue. However, what you're just looking at is to see whether or not you need to stay at 23 or go up to 24. And what you can see is that 23.778 is closer to 24 than 23. The nearest order of magnitude will be 10 to the 24 atoms. So when you're just talking a general estimation and you're talking about the nearest order of magnitude, this 10 to the 23, 6 times 10 to the 23 is exact, but its nearest order of magnitude is actually 10 to the 24th atoms. Okay, let's try another one. The length of a virus is 2.3 times 10 to the negative 8 meters. Now we know that viruses are really tiny. We can't see them but with a microscope, right? Except for with a microscope. So take the log, you get this number, and what we're looking for is to see whether or not it is wanting to stay at this number or go up. So negative 7.6382 is closer to negative 8 than it is to negative 7, so therefore our nearest order of magnitude is going to be 10 to the negative 8, which is pretty much what it already is, so it just works out well that way. Now, you are going to know, you are going to be required to know some things in for the physics IB. So the smallest objects you need to know are the subatomic particles, such as the protons and the neutrons. You need to know that they are to the nearest order of magnitude 10 to the negative 15. And that's in meters. The largest objects you need to know is the universe. And its size is 10 to the 25th meters. Its mass is 10 to the 53 meters. And this is, again, nearest order of magnitude. What this looks like, if you were to compare the size, right? You also need to know the masses. The lightest mass that you need to know is the electron, and its nearest order of magnitude is 10 to the negative 30 kilograms. The heaviest mass is the universe, and that order of magnitude, the nearest order of magnitude, is 10 to the 53. This is what I wanted to show you, just to get an idea if you had to compare the lightest versus the heaviest. That many zeros in front, so that's how tiny the electron is. And this is how big the universe is in kilograms, in mass. So to kind of get an idea. So it's super tiny and really large. So you are going to need to also know the smallest time interval, and that is the time that it takes light to travel across a nucleus. So in regards to time being equal to distance and speed for light, you are going to know that the nearest order of magnitude for this is 10.23 seconds. The longest interval you need to know is the age of the universe, which we know the age of the universe to be about 12 to 14 billion years old. And the nearest order of magnitude is 10 to the 18th seconds. You do have to learn these things. So you can write this down if you want, otherwise you can revisit this video at a later date. But you do need to know 10 to the negative 15 meters to 10 to the 25 meters for sizes. And these are like from subatomic particles to the visible universe. For masses, you need to know from 10 to the negative 30 kilograms, such as the mass of an electron, to 10 to the 50 kilograms, which is the mass of the universe. As for time, you need to know the time for light to cross a nucleus, which is 10 to the negative 23 seconds, and 10 to the 18th second, which is the age of the universe. So these are just things that you're going to have to learn, okay? So just memorize them, use them often in your speech, and then maybe it won't be so hard to remember, but we do need to know this. Okay, so for estimation, you have to be able to make order of magnitude estimates, okay? We're going to have some practice after this. So when you're making estimation, here's an example. So I've got 3 lines here. The first line is 1 millimeter. It has a magnitude of 10 to the negative centimeters because 10 to the negative 1 is 0.1 centimeters or 1 millimeter. The second line is 10 millimeters long, and it is 10 to the 0 magnitude, or it's also 1 centimeter because there's 10 millimeters in 1 centimeter. The third line is 10 centimeters, and it has a power of 1. Now, if I had this line, it's the longest one, I can estimate this to the nearest order of magnitude. It would be closest to the 10 to the 1. As you can see here, seems pretty simple. It would be, the nearest order of magnitude would be 10 to the 1. The second line would be closest to the 10 to the 0. But what happened about this line? This line is kind of short for being 10 to the 1, but it's a little too long to be estimated 10 to the 0. So let's go ahead and measure it using this ruler down here. And we have a measurement of 3.3 centimeters. So what I'm thinking is it's larger than a centimeter, it's shorter than 10 centimeters. Couldn't I have a power of 10 to the 0.5? That would be kind of nice. So if we took this and put this value into the calculator, we would get an answer of 3.16. Okay, so because 3.3 is greater than 3.16, the exponent is larger than this 0.5, so the nearest order of magnitude is going to be 10 to the power of 1. Okay, so this is going to be a general rule that you're going to use in order to estimate anything from here on out. So the rule is, if the first 2 digits are larger than 3.2, then you can go to the higher exponent. If the first 2 digits are less than 3.2, you go down to the lower exponent. And this just kind of helps you to realize that maybe it's somewhere in between these two, okay? So if it's 10 to the 0.5, then you know that, okay, if it's higher than 3.2, then you go up to 10 to the 1. And if it's less than, then you just go to 10 to the 0. Okay, so let's go ahead and estimate this apple to the nearest order of magnitude. So all I need is a power of 10. So here's the apple. If we say an apple, maybe I did some research, or maybe I kind of know. I know that on average an apple is about 200 grams, but we need to work in kilograms. So let's go ahead and change this. So 200 grams is So we know that grams into kilograms, there's 1,000 grams for every kilogram. So what that turns out into is 0.2 kilograms, which is, if you were to take this decimal point and put it over here and make it into the scientific notation, it would be 10 to the negative 1. Okay, so that is my order of magnitude. For estimating the following, let's go ahead and estimate this one, okay? So the nearest order of magnitude, the number of times a heart beats, a human heart beats in a lifetime. So this is going to be, a little bit more involved than trying to figure out the apple, okay? So let's think about how long a human might live. So let's say 80 years, okay? So we know we need to get down to heartbeats, and we usually measure those heartbeats in minutes and okay, so we're going to go by minutes. So let's do years. So we know for every year there's 365 days. For every day there's 24 hours. For every hour there's 60 minutes. And let's go even further. 1 minute is about, and this is you have to either do some research or you just have to be reasonable and common sense that a resting heartbeat is about 70 beats per minute, okay? So let's go ahead and cancel. Years cross out, days, hours, minutes, and what you're left with is heartbeats, and when you're going to multiply all the stuff on the top, you should get this answer. So what we have is 369. So 2.9 times 10 to the 9. So your estimate to the nearest order of magnitude is 10 to the 9. Or, oops, that should be 9, not negative 9. Okay, so 10 to the 9. Okay, so comparing the order of magnitude of two different objects, you will be asked to understand order of magnitude for an object, and you are also going to need to compare two objects and be able to explain how they are connected. So, compare the mass of the apple with the mass of the earth. We've already discussed what the apple was, right? So the apple was 2 times 10 to the negative 1 kilogram, and don't worry about that. Then the earth is 6 times 10 to the 24th kilogram, which is its order of magnitude 10 to the 25 after you do the log and you figure out that this number is closer to 25. So, and of course this is still 10 to the negative 1. So you're going to create the ratio. You have 10 to the 25 over 10 to the negative 1, which gives you an order of adding these exponents, gives you 10 to the 26. So the Earth is 26 orders of magnitude larger than the apple. Or another way to say it is that the Earth's mass is the apple's mass times 10 to the 26 kilograms. Here is another common ratio. You need to learn this. The hydrogen atom, here it is, 10 to the negative 10 meters versus the proton of that same atom, 10 to the negative 15. The proton is smaller than the atom. Now, the ratio of the diameter of the hydrogen atom to its nucleus is this answer here, 10 to the 5. So you can say that the hydrogen atom's diameter is the proton's diameter times 10 to the 5th meters. It doesn't mean that it is 5 times more. It means that it is to the magnitude. So it's 10 to the power of 5 times more. Okay? All right, so just be ready to use this in your next assignment or in class.